Welcome, my friends. Oftentimes, we want to count the total number of ways that some event can happen, or perhaps the total number of possible events in the sample space of a statistical experiment. Being familiar with what are called counting techniques can help us answer more advanced probability questions. The three counting techniques that we will discuss are the multiplication rule of counting, permutations, and combinations. We will look at the multiplication rule of counting and permutations in this video, and combinations in the next video. The multiplication rule of counting can be used to calculate the total number of outcomes related to a series of ordered events. Put simply, if there are A ways of doing one thing and B ways of doing another thing, then there are A times B ways of doing both things. This can also be applied to more than two events. For example, if I'm at a restaurant, I might have 3 choices for appetizers, 5 drink choices, 4 choices for the main course, and 2 desserts. How many ways are there to choose a meal if I must select one of each? The multiplication rule of counting says that I can simply take the number of ways to choose each part of the meal and multiply them together. So 3 appetizers times 5 drinks times 4 main courses times 2 desserts is equal to 120. There are 120 possible meals with one of each choice at this restaurant. Consider this question. In a 100-meter dash with 8 runners, how many ways are there for the places 1 through 8 to be awarded? Listing all of the ways that the 8 runners could place would be very tedious and difficult and take a very long time. To see why, consider a few of the specific outcomes. One outcome could include the runner in lane 1, or R1, placing first, the runner in lane 2, or R2, placing second, all the way through R8 in last. Or we could have the exact same outcome, except that R2 comes in first and R1 comes in second. Or R7 comes in last and R8 comes in second to last. You can start to see how difficult it would be to list all of the outcomes. Luckily, we have methods to count how many ways there are for the 8 runners to place without listing them all. This is just the multiplication rule for counting that we discussed a minute ago. There are 8 runners, so 8 ways first place could be awarded. But once the first place runner has finished, there are only 7 runners remaining that must compete for second place. Once second place finishes, there are 6 runners remaining competing for third place, etc. all the way down to 1. The multiplication rule for counting tells us that we can multiply all of these numbers together to get the total number of ways the places can be awarded. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is equal to 40,320. There are 40,320 ways that the runners can finish. The above multiplication can be represented by 8 with an exclamation mark after it, read 8 factorial. The factorial symbol simply tells you to multiply the number in front of the factorial by that number minus 1, then that number minus 2, continuing until you get down to 1. In general, n factorial equals n times n minus 1 times n minus 2, continuing until you get down to 1. This is exactly what we have. N is 8, so we start with 8, then multiply by n minus 1, which is 7, then n minus 2, which is 6, etc. until we get down to 1. n factorial represents the number of ways to arrange n objects, just like 8 factorial represented the number of ways the 8 runners could finish the race. Note that for a variety of reasons, we define 0 factorial as being equal to 1. This is convenient for many of the formulas factorials are used in, which we will look at later. Now, what if we have n objects, but we don't want to arrange all n of them? How would we proceed? Well, we can use the idea of factorial, but we just have to stop earlier. For example, let's take the same case with the 8 runners in the 100-meter dash, but now we are only interested in the number of ways there are to award first, second, and third place. So I have 8 objects, or 8 runners, and I want to award 3 places, first, second, and third. Use the exact same idea as earlier. It's just the multiplication rule, but we only have 3 places to award instead of 8 this time. Any of the 8 runners could win first place, Once first place finishes, there are 7 runners competing for second place, and once second place finishes, there are 6 runners competing for third place. Multiplying these 3 numbers together gives us 336. So there are 336 ways to award first, second, and third place from a pool of 8 runners. Now what we've done here is the multiplication rule for counting, but it happens to be a special case of another counting technique called a permutation. A permutation is a method of counting that can be used when both the following conditions are met. We are sampling without replacement, and the order that the objects are chosen matters. Sampling without replacement means that once an object is chosen, it can't be chosen again. Like once the runner comes in first, he can't also come in second. The order that the objects are chosen mattering in our example means that we don't just care which 3 runners are chosen, we also care what place they came in, first, second, or third. Notationally, n represents the total number of objects and r represents the number of objects being chosen. We write the permutation of n choose r in one of these 3 ways. I will be using the first version of NPR. Let's take a look at a few examples to make sure you get the idea. The permutation of 8 runners choose 3 is written like this, and is equal to 8 times 7 times 6, or 336. Always start with n and multiply by the next smaller number until you have r numbers, in this case 3. The permutation of 10 choose 5 would start at n, in this case 10, and multiply r numbers together, or 5 numbers together in our case, each incrementing down by 1. So the permutation of 10 choose 5 is 10 times 9 times 8 times 7 times 6, which is equal to 30,240. There are 30,240 ways to arrange 5 objects from a group of 10 objects. The permutation of 22 choose 4 is 22 times 21 times 20 times 19, or 175,560. Hopefully you're starting to get the idea. Now when r gets large, calculating permutations in this way can get tedious. For example, consider the permutation 15 choose 12. That would be 15 times 14 times 13, etc. all the way until we get to 4, so that we have 12 numbers. Instead of using this method, there is actually a formula you can use in these situations. And that formula is that the permutation of n choose r is equal to n factorial divided by n minus r factorial. In our case, we have n equals 15 and r equals 12. So we have 15 factorial divided by 15 minus 12 factorial. This simplifies to 15 factorial divided by 3 factorial. Simplifying the denominator, we have 3 times 2 times 1, or 6. Now you might be thinking to yourself, how does this save me any time? Now you need to calculate 15 factorial, which is even more numbers to plug into your calculator than the permutation of 15 choose 12. Well, to answer that, we need to venture to our calculator. So we need to calculate 15 factorial and divide by 6. Most scientific calculators have a factorial key. First, type in the number that you want to apply the factorial to, which in our case is 15. Then search for the exclamation mark, which is the factorial key. For this calculator, you must press Math, and then you can arrow over once to the left to get to the probability menu. And then you'll see here that you can select option 4, which is the factorial key. Now I can divide by 6 to get the answer. The answer is so big that we are getting scientific notation, basically saying to move this decimal place 11 places to the right, which actually makes this number around 218 billion. If you have a TI-83 or 84 calculator, you can skip all of this and go right to your calculator's permutation and combination keys. First type in n, which is 15 for us, then press Math, arrow over once to the left and choose option 2. Now type r, which is 12. Press enter and you should get the same answer. For me, I typically use the multiplication rule idea for permutations. That, for example, the permutation of 8 choose 3 is just 8 times 7 times 6, unless r is really big, and in that case I just use my calculator's permutation key. I rarely, if ever, use the formula, but I know that it's there as an option, and some teachers will require that you use it. Alright, my friends, we have finished our example of the multiplication rule and permutations. We will be looking at another counting technique called combinations in the next video, so make sure to come back for more.